Hello everyone, welcome back to my channel Learning Fundamentals by Ankit Shukla. I hope you're all doing well. Today we are going to learn about DNS records. In our previous session we have learned about how DNS works in an IT infrastructure. So without wasting any time, let's understand what are DNS records and how they are used in real world scenarios. What are DNS records? DNS records are entries in the domain name system that tell the internet where to find specific resources on a domain, like a website or email server. You can think about DNS as a record or something like an entry in an address book for the internet. It is like for everything used or published on internet, we have a DNS record. DNS records are like data entries in the domain name system that provide information about a domain, an IP address, mail servers, or other key details. These records are used to translate human friendly domain names like google.com, example.com, or any domain that is available or published on the internet into machine friendly IP addresses. Machines do not know the names, they interact with each other in IP addresses. So basically DNS records help you identify or provide the information about a domain and translate that to IP addresses, the domain names to IP addresses. And that allows the users or businesses across the globe to access different websites and other online resources. You can say in simple terms that DNS records are like a directory or a phone book for the internet, which guides the internet traffic to the right place. For example, the IP address of the website which is published on a name server somewhere on the internet is represented by an A record. Another example for is like mail receiving server of a company which has an IP address which is referred as MX record. Let's explore what are these DNS records. Most common types of DNS records are A record, CNAME record, MX record, TXT record, NS record, PTR record, AAA record. Here's a simple breakdown of most common types of DNS records. A records basically maps a domain name to an IP address. For example, it tells your computer that google.com or example.com or any domain.com should be reached at a specific IP address like 192.168.0.1. Next on the list we have CNAME record. CNAME records are canonical name records or alias records. It points one domain name to another domain name. For instance, if you have a domain like www.example.com and you want it to point to example.com, you would use a CNAME record. Let's talk about MX record, mail exchanger record. It directs email to the servers responsible for handling inbound emails for the domain. If you send an email to someone at example.com or some company name.com, the MX record will tell you that their email provider, they tell your email provider where to send that email to or where to deliver that email to. Next up is TXT record or text record. It allows the domain owner, the company that owns a specific domain, to store the text information. It's often used for things like verifying domain ownership, setting up email authentication or email security records like SPF and DKIM, or even storing the security related information as well. Then we have NS record, referred as name server record. It specifies the authoritative name servers for the domain, which are the servers that holds the DNS record for that domain. I covered the authoritative name servers in the previous session where I covered about the DNS and the DNS zones and how DNS resolution works. Then we have PTR records. It's used for reverse DNS lookup, which basically means that it maps an IP address to a domain name or a host name. Then we have AA record. It's similar to an A record, but it points to an IPv6 address. A record points to an IPv4. AA points to an IPv6 instead of an IPv4. In short, you can say that DNS records are the backbone of how the internet functions, ensuring that all requests for domain names are directed to the correct servers for different services, and that allows users to access websites, send emails, or use other online services efficiently and securely. Let's do a deep dive into what these DNS records are in detail and how they function, their advantages. So first up, we have A record. What is an A record? These are the most common type of DNS records. An A record in DNS is a fundamental type of DNS record that links a domain name to its corresponding IPv address or IPv4 address. It's one of the most basic or and commonly used DNS record. It plays a very critical role in ensuring that when users type a domain name into their browser, they are directed to the correct web server. A record maps a domain name to an IP address. For example, it tells your computer that www.example.com should be reached at a specific IP address, let's say 192.168.0.1. What this means in simple language is that if you type www.example.com in your browser, your computer will use the DNS to find out that www.example.com corresponds to an IP address like 192.168.0.1. This process involves looking up the A record for this website in the global DNS. Next up, this is how you can say this is a schematic representation of how an A record works. First up, we have mapping domain to IP. In A record resolution, basically first map the domain name to the IP address. The primary function of A record is to associate the human readable domain name like example.com with a numerical IP address that machines can understand. The IP address is here, or you can say it is where the website or service is actually hosted on the internet, the authoritative servers. The A record also simplifies the accesses, like users prefer using domain names. We use names instead of IP or numbers because they are easier to remember, right? And we can't recognize IP addresses, to be very honest, right? The A record makes it easy for us, or it makes it possible for us to type a simple URL, which behind the scenes the DNS translate that URL to the IP address of the server which is hosting the website. Then another advantage, or you can say, with A record is that it has one-to-many relationship, one to multiple. A single domain can have multiple A records, each pointing to different IP address. This is often done for load balancing, where traffic is distributed across several servers, and for redundancy, ensuring that if one server goes down, others can handle the traffic. I need you to pay a close attention to this diagram right now and understand the workflow on how A record helps you resolve the IP address or resolve the name of the website to an IP address. First up, you have your device. You open a website, let's say www.mywebsite.com on your device. The request first goes to your resolver, which would be your ISP or your network provider. Then the resolver starts a recursive query to the nearest root name server. I'm sorry, over here. Resolving name server goes to your root name server. Then root name server basically gives the top level domain name server information of the website. In case it's a .com domain, so it will be a .com TLD name server. If it was a different extension like .in, .au, .nz, .uk, it will be their corresponding top level domain name server. Then the top level domain or TLD name server has the information about the authoritative name server for this specific website, where this website is actually hosted. which further refers the DNS records, the A record for this website, which is stored in the authoritative server. Then finally, from DNS records, the site information, which are stored on the web server, maybe like a directory, is then pulls up the file information which are stored on this web server database, and then these are retrieved and cascaded or passed on to your source device over here, which requested for the website in the initial phase. Now this tells you how an A record is eventually resolved through different hops of servers, starting from a resolver. Then resolver runs a recursive query that goes to a root server. Then root server redirects that to the top level domain server. If it's a .com domain, it will be a .com TLD server. Then .com TLD servers has the list of the, or has the information about the authoritative server, which then pulls up the DNS records because it is the owner of the website where it was hosted, or that domain that was created initially. Then it refers the file which are stored for that website. There may be certain records, pictures, HTML documents, or whatever it is. It then fetches that information and then passes on to the web client of the source device from where the query was initiated. So you can understand that all these things happen behind the scenes in a fraction of a second, which can make you understand the existence of servers meant for DNS purposes and the importance of A record in our day-to-day life. Let's move on to our next DNS record, which we have, which is CNAME. What is a CNAME record? A CNAME record, or canonical name record, or alias record, is used in DNS to map an alias or subdomain to another domain name, which is the canonical or primary domain name. Here is a detailed explanation of how CNAME is and what's the purpose of it. Alias creation. It allows you to create a domain alias that points to another domain. For example, blog.example.com. It can be an alias for exampleblog.com. When users access blog.example.com, they are directed to exampleblog.com. What is an alias? Alias is nothing but a pet name, like we use in day-to-day life. Someone is referred to, or you can say like most of us have a pet name or nickname which our friends use while referring to us or calling out our name. Similarly, in digital world or internet world, you can say that CNAME records are used as alias for a domain when a specific service with respect to that domain is referred to or called for. It is like a redirection record with respect to service of a domain when called for. Then second part of CNAME is simplified management. It simplifies the DNS management by letting you update the IP address or other things of the canonical domain name without changing the alias record. Let's understand how CNAME works. Now, look at this diagram on the right hand side very carefully. We have a root domain name, which is company.com. We have a CNAME record for this domain, which let's say a user accesses that is www.company.com. Of course, the CNAME for the company.com domain. Now, in this, the DNS resolution process for CNAME record work in this sequential order. The A record of this domain name translates the domain name company.com into a corresponding IP address that we learned from the A record in the previous or just 2 minutes back. Then once you open a browser or on a network device, you open a specific address, that is www.company.com. That's where DNS query goes to your resolver, which finds the authoritative name server eventually after root domain, TLDs and all that. That authoritative server holds the DNS zone file, which has appropriate DNS records for company.com. That's the original domain name or the root domain name. The CNAME record is returned to the client. Now, DNS clients understand that www.company.com is an alias of the root domain, which is company.com, and then it issues a new DNS query for company.com. The same request process is repeated, and this time the resolver returns the A record of company.com instead of www.company.com with its IP address. Then the client or the requested machine connects to the company.com using its IP address. Let's see another example of CNAME. Now, in this example, a person opens a web page finance.company.com, right? The DNS recursive resolver runs the query through DNS root server, which in turn gives the information to the TLD servers. Then the TLD name server routes query to the authoritative name server of company.com, the root domain. Then the authoritative name server, known as the top level domain, right? It has the CNAME alias for the finance.company.com by looking into the zone file or the zone or the DNS file record information of that domain, because it already holds the website data. Then it shares the and then identifies that the CNAME that the client is requesting, it is pointing to the same IP address as the root domain name, right? So the CNAME basically points to the same IP address, which is the A record of the domain. Then this is a clear explanation of CNAME record over the internet, and I hope this helped you understand how CNAME works as an alias for the domain name. Let's move on to the next record, which plays a very important part of our day-to-day life, which is MX, or you can say mail exchanger record. What is an MX record? An MX record is a DNS record which specifies that specifies the mail server which is responsible for receiving and handling emails for a domain. Here's a detailed look at how it works and its components. Its purpose. The purpose of an MX record is that the MX record directs email to the correct mail server for a domain, ensuring that the incoming emails are routed properly. Let's understand how DNS works. Basically, there is a DNS query that is initiated. Basically, when an email is sent to an address like user@example.com, the sending mail server queries the DNS to find the MX record of domain.com, which is example.com in this case. Then the DNS responds with a list of MX records which are published on the authoritative server. Each MX record is associated with a priority and a mail server's domain name. Then the sending email server attempts to deliver the email to the mail servers listed in the MX record, starting with the highest priority. When we say highest priority, it means lower the number, higher the priority. So if the primary server, let's say a mail server that has low priority, that is going to be tried first for sending the email. If that server is unavailable, it will try the next one based on the priority. So it's like 0, 5, 10, 15, 20 and goes on. So it starts with 0, whatever the record name is there on priority 0, it will first try that server. If that is not available, it will move on to the next one, which is based on the priority. Let's understand the components of MX record, priority and mail server domain. Priority, you can understand from MX perspective that it's an integer that indicates the order in which the mail servers should be used. Lower the number, higher the priority. For example, if you have MX records that has two priorities, 10 and 20, mail will first be delivered or sent over to the server with priority 10. If it's unavailable, then the server with priority 20 would be used. Second part of the components of MX record is mail server domain. It defines the domain name of the mail server where emails should be delivered to. An example record of a mail server domain would be mail.example.com. That will be the mail server domain name for example.com. So example.com is the domain name. Its mail server domain name would probably be, or as an example, mail.example.com. Next, this is a example, or you can say this is how your MX works, as I was explaining. Assume that there is a mail server somewhere on the internet, and then it wants to send an email to me. My company domain name is company.com, and my email address is ankit@company.com. The server will need to find out the name or probably an IP address of the mail server, which is responsible for company.com, which is my company name, right? So for company.com, there would be a server or a name of the server which will be responsible for handling or receiving the incoming emails which are directed towards my organization, right? So if you see on the left hand side, this is your sending server. This is my DNS, my authoritative server. The remote server queries to the DNS server that they need the MX record for example.com, right? Or let's say company.com. If there is no MX record, then it will try again in the second step. However, generally you will find the MX records and the DNS will reply with the correct MX record. This is the mail server domain, which is mx.company.com. So if any email that is sent to this address mx.company.com, it will eventually land up at my receiving server. If there is no MX record, then the sending server will ask for an A record, which is like the fallback solution. In case this mx.company.com does not work, then it will ask for the A record of mx.company.com or company.com, which will probably be something like an example 100.20.10.77. This is how MX works in real world scenarios. Let's talk about some key points of MX record and their advantages. Multiple records can be there for MX. You can have multiple MX records for a domain, which allows for load balancing and redundancy. Then it helps you with the hostname resolution. The mail server domain specified in the MX records must resolve to a valid IP address through A record or AA records. Then third key point about MX is it has a time to live, TTL, which determines that how long DNS resolvers should cache the record. So if you remember, resolvers are the DNS servers which cache those records. So in case if a company sends you that email, sends you an email, and their resolver is able to identify that X and X, your domain name or example.com has some IP address for mail services, right? So eventually once your device or your sending server has that information, it will cache that information in the resolver as well, the sending side. This TTL value that you define in your DNS record means that that is the duration or the timeline during till which the resolver will be able to cache this information, post which they have to remove this cache record. Now, what are the benefits of having MX? That it allows for redundancy and load balancing. Let's say a classical case of redundancy would be that if one server fails, another one can handle the emails in the priority order. And then with respect to load balancing, it distributes the email traffic among multiple servers based on their priority, right? That is an example of load balancing. Let's move on to our next DNS record, which is TXT or text record. A text record is a type of DNS record used to store arbitrary textual information or text information associated with the domain. This information can be used for various purposes like domain verification, email security, and providing additional details about the domain, like or you can say let's have a detailed look at what are TXT records, right? The purpose of TXT records is that it allows for domain verification, TXT records are commonly used by services like Google, Microsoft, Amazon to verify domain ownership. Basically, TXT record, if you choose to use any service with any cloud service provider, they will ask you to verify your domain ownership for using their service on cloud. They'll give you some value, some text value that you need to update in the form of a TXT record on your authoritative server. An example would be GoDaddy. So wherever you purchase your domain, or wherever your domain is hosted, that's your authoritative server. You would have to update your TXT record that is given by your service provider, let's say Google or Microsoft. And then once you update that, they'll be able to verify that from public DNS query or recursive query. They will be able to fetch this TXT record that will prove that you are the owner of the domain. Next up, we have email security. That's the one of the other purpose of TXT record. TXT records are used for implementing email security protocols like SPF and DKIM. SPF stands for Center Policy Framework. DKIM stands for Domain Keys Identified Emails. These protocols help you prevent email spoofing and ensures that the emails are from legit sources. Then third purpose would be some other information, right? For TXT records can store any text-based information that domain administrators want to include or network administrators want to include, such as contact details or some additional configuration data. TXT can have other set of information as well. Let's understand how TXT actually works. First up, again, just like all the other records, DNS query is initiated. When a service or application needs to update their TXT record for a domain, it queries a DNS first. Then once that query is able to identify the TXT record for the domain, the DNS server returns the TXT record, which contains the text information from the requester to the requester. Then the retrieved information that is received by the requester is then used for the intended purpose, like domain verification or verifying or checking the email security settings for your domain. That's that's how the TXT record works. If you see in this example, we're going to talk about structure and examples of the TXT record. This is the structure of a TXT record. It will have a name, it will have a type, it will have a value. The name defines the a specific service or the text value for that domain. So for example, if you have an SPF record for email verification, the name will display the domain name, let's say example.com, and then the TXT value that is in the third section, it will display spf.example.com or something.example.com, right? Then it has type, which means it, of course, it's a TXT record, so the type would be TXT, and then it has the value. Then let's look at some examples of TXT record, right? Now let's say we are talking about domain verification. For domain verification, an example would be, let's say, if my domain is hosted on Google, let's say Google is my authoritative server, right? Let's say my domain name is example.com, right? The name would be example.com, the type of record would be TXT, and then the value, so whatever values that Google gives me to update on my authoritative server, wherever my domain was purchased from, wherever the domain is hosted on, I need to update that record. So if you see, this is the value of that TXT that Google provided me to update. Another example would be looking at the SPF record, right? To which the SPF record, just to inform you or make you aware, it basically specifies that which email servers are allowed to send emails on behalf of the domain. So it's like MX is for inbound emails, SPF is for outbound emails. It is the servers which actually are allowed to send emails out of the organization. In case of SPF, the name would be example.com. Again, the domain name would be reflected in the name section. The type of record would be TXT, and then it has a value. So over here it reflects the SPF record on how it should be updated as a TXT on your authoritative public DNS servers. And so we have DKIM as well, right? We will learn about DKIM and SPF when we start our sessions for Microsoft 365 and Exchange Online, because these are very, very important records with respect to email security. All right, let's move on to our next DNS record, which is name server or NS, Nancy Saya record. A name server record, it's a type of DNS record that specifies the authoritative DNS servers for a domain. We have been talking about authoritative servers for a long time. Let's understand what exactly these authoritative DNS servers are. These servers are responsible for providing the DNS information for the domain, including resolving queries for subdomains and other records associated with the domain. So all these records are actually stored on the authoritative server, which is again represented by a record which is called as name server record. What is the purpose? They are used for delegation. The name server record delegates the responsibility of managing DNS records of a domain to specific DNS records. This is essential for ensuring that the DNS queries for the domain are directed to the correct authoritative servers. Then they also help with the domain resolution. They are crucial in the DNS resolution process. They also guide you on how DNS queries are handled and resolved. Let's look at how name server record works. The first query happen as usual from your device. It goes to your DNS resolver to find information about the domain. It starts by querying the root DNS server. So that is the first DNS query. Then the resolver routes those query to root servers. The root servers direct the resolver to the authoritative name servers for the domain's top level domain, which means the TLD servers are after the root servers. Then in TLD servers, they redirect the resolver to the authoritative name server for the specific domain. And then you finally have the authoritative name servers. These name servers are specified by the NS records for the domain, which provide the final DNS answer for the domain, including resolving queries for subdomains and other records. Let's understand the components and some examples of NS records. We have three components in name server record, just like other records we had. We have name, type, and value. The name defines the domain name for which the name server record is applied. For example, google.com. Type would be NS, just like TXT. The type here would be NS. That indicates that it's the name server record, right? Then it has a value, the domain name of the authoritative name server. Let's say you buy, your domain name is google.com, example. Then your name server will probably be like ns1.example.com or ns2.example.com. And that's how, if you see in the examples I have displayed over there, name, type, value. So for one domain, there could be two or more. Generally, it is two at least, and then you can have more than two or three or maybe four name servers as well for each individual domain name. Again, name servers are authoritative servers. These are the servers that hold the domain data, the domain information, the DNS zone, and the zone file, which actually will tell or share the or give you the information about the other DNS records. Now, in this example, the DNS queries for example.com, that's the domain name, will be directed to the first server, which is ns1.example.com and ns2.example.com for resolution. Now let's understand the key points and benefits of name server records. There are three key points of name server records. First is multiple records. You can specify multiple name server records, as I explained in the previous slide, for a domain to ensure that redundancy and reliability is there. If one name server fails, others can handle the query. Then it helps with the host name resolution. the value of a name server record must resolve to an IP address through an A record or a AA record, right? Which means that that ns1.example.com should have a corresponding A record or a AA record. A record stands for your uh, your website, right? It is pointing to an IPv4 address, and then AA, again, that stands for websites, but that points to IPv6 address. The third key point of a name server is delegation. Name server records are used to delegate DNS authority from parent domains to child domains or subdomains, right? For example, if google.com delegates authority to some child domain, let's say india.google.com, right? The name server record for india.google.com will be managed separately, right? Then there are two different or very important benefits of name server record. First one being redundancy, second one being scalability. Using multiple name server records ensures that the DNS queries can still be resolved even if one or more name servers or NS servers are unavailable, right? So choosing to have multiple name servers it is actually beneficial for a company in terms of redundancy, that even if one or two servers are down, the queries can still be answered by the other name servers or other authoritative servers. Other advantage of a name server record is scalability. It allows for the distribution of DNS management across different servers, which can be useful for load balancing and handling high traffic. Alright folks, this is the end of session 4, where we learned about different DNS records like A record, MX record, CNAME record, name server record, and TXT record. There are other records as well, like SOA records, PITR records, which will be covered up in a different topic. But yeah, these 5 that we talked about today are the top priority, or you can say most important DNS records. We have understood that why these records are most important DNS records and how they are used along with the benefits and their role in DNS structure of a website, server, or different services associated with an IT infrastructure. If you found this session helpful, insightful, please don't forget to like, subscribe, and hit the bell notification so that you can be updated with more content on IT learning and network technologies. I would love to hear your thoughts, so please leave a comment or question below. Thank you for joining this session, and until next time, keep exploring, keep learning, and remember that behind every click lies a world of fascinating technology. This is me, Ankit Shukla, sign off. Take care everyone, and I will see you in the next video.